Some two-column proofs ask you just to prove two triangles congruent. Some ask you to prove that some line segment is congruent to another one, or some angle is congruent to another one. And those require an extra step after the triangles are congruent. And some, like this one, ask you to prove something like D is the midpoint of BC. So I want to show you how that works. So we could even write in, we know it has to end with D is the midpoint of BC. But what's the reason going to be? Well, if we knew D was the midpoint, we could say that BD equals CD, and that works the other way around also. If it was true that BD equals CD, and I'm writing this because I know it needs to be here, but not because I know that it's true yet. But that would lead me to the midpoint. Then I could say definition of midpoint. But why is BD congruent to CD? Well, that's where we build up from the beginning now with two-column proof. Angle 1 is congruent to angle 2, that's given. There's only two triangles in this picture, so I must be working towards proving those two triangles congruent. They share side DA, reflexive. So now I have this. And when they tell me AD is perpendicular to BC, it does take me two steps, but I can say that I could draw in this, which makes me feel like I just know they're congruent, but it takes two steps. You say that angle ADB and angle ADC are right angles. Definition of perpendicular. Then we can say angle ADB is congruent to angle ADC. All right angles are congruent. Now I have these two triangles I got the angles, the side, and the angles, so my reason is going to be ASA. You definitely need to have 1, 2, 3 congruent statements before you can say something like ASA or SAS. So if you try to skip this step here, that would not be as accurate. Now, if instead they asked you something like prove AD bisects segment BC, that would require an extra step, because to prove something bisects something else, you need to show that it's the midpoint. So we're already practically there, but then we'd have one more step, AD bisects BC. And our final reason would be definition of segment bisector. So a couple of videos ago, I showed you how often proofs end right here, proving the triangle is congruent. In this one, we see that sometimes, looks like I have a big step missing. Sorry about that. Can't say this yet. You don't say that those are congruent because of ASA. You say the triangles are. Then you have to say CPCTC to say that BD is congruent to CD. Sorry about that mix up. CPCTC is why BD is congruent to CD. I should probably re-record the video, but I have too many videos to make, so I'm moving forward.